Timeless concepts from Physics Helpline. In this video tutorial, we will discuss a multiple choice question on the force between two straight conductors carrying current. The question is as follows. Read the question carefully. The situation is shown in the figure. We are given three infinitely long straight conductors A, B and C. A and B both carry currents equal to I and they are in the upward direction, and C carries a current 2I in the downward direction. The distance between A and B is equal to x. The distance between B and C is also equal to x. Now, the force per unit length of A due to current in B is F1 and the force per unit length of A due to current in C is F2. We are required to establish a relation between F1 and F2. This will be a vector relation. Now for the answer. First, the magnetic field at A due to B. The current in B is I and distance from A is equal to x. Therefore, we denote it as B1 mu 0 I by 2 pi x. What will be the direction? If we hold the conductor B in our right hand with thumb pointing in the direction of current, the curling fingers at A will be perpendicular to the plane of the figure and out of it, which is the positive direction of z-axis. Therefore, we write B1 vector is equal to mu 0 I by 2 pi x into k cap. Now, the force per unit length of A due to current in B, which is force per unit length of A due to magnetic field B1. Therefore, we will use the equation F1 is equal to I into L cross B1. Now this I is the current in A, therefore we put it is equal to I only, and length, because we want the force per unit length, we put L is equal to 1, and magnitude of B1 is mu 0 I by 2 pi x, and the cross product, unit vector along L and unit vector along B1. Unit vector along L is nothing but the current. This is your upward direction, which is j cap, and unit vector of B1 is k cap. Therefore, j cap cross k cap gives us I cap. Therefore, we get vector F1 is equal to mu 0 I square. I into I is I square divided by 2 pi x into I cap. Similarly, magnetic field at A due to conductor C. Now, conductor C carries a current 2I and its distance from A is 2x. We'll put these values. So, B2 is equal to mu 0 into current is 2I divided by 2 pi into distance is 2x. And what will be the direction? If we hold conductor C in our right hand with thumb pointing downwards in the direction of current, then the curling fingers at A will be into the plane of the figure, which is the negative z direction, represented by minus k cap. And this 2 and 2 gets cancelled, giving us mu 0 I by 2 pi x into minus k cap. And the force per unit length of A due to current in C, which is nothing but force per unit length of A due to B2. Therefore, we write the general equation F2 is equal to I into L cross B2, because I is the current through A. The value of current is I, therefore we put I, and length L, because we want force per unit length, putting L is equal to 1, and B2, magnitude of B2 is mu 0 I by 2 pi x, and the cross product of unit vectors. L is in the direction of, because this is the current through A, so L is the IL has the direction of J cap plus J cap, and the magnetic field B2 has the direction of minus K cap. Therefore, we write minus J cross K. Now, J cross K is equal to I. Therefore, minus J cross K is equal to minus I. Therefore, F2 is equal to mu 0 I square divided by 2 pi x into minus I cap. It is clear from equations 1 and 2 that the magnitudes of F1 and F2 are all equal. It's only direction of F1 is plus I cap and direction of F2 is minus I cap. Therefore, F1 and F2 are equal and opposite. Therefore, we write F1 is equal to minus F2, which is the answer to the question. Therefore, the correct option is D. This completes the answer to the question. Thanks for watching. If the video is helpful, then please like, share and subscribe.